Good evening. So today we are going to discuss about assignment 7, that is transformers. In this assignment, we are going to discuss. We are going to get a better understanding how transformer works and uh, how they can be fine-tuned for this special natural language processing task. So we are going to use a pre-trained bidirectional encoders representations from transformers in this particular assignment. So for that, we are supposed to use a GPU. So we are running it in the Google Colab. So, and first of all, we are going to install the transformers like install Hugging Face transformers. For that, we are going to use a pip install transformers slash u, and we are going to obtain the dataset from the GitHub. That is a toxic comments dataset. So that is toxiccomment.csv. So we after successfully downloading everything, so now we are going to import the packages that are required for that, and so these are all the packages that we are going to use in this assignment. So that's NumPy, Pandas, and Torch, the skeleton model, and the transformer package. So so for the in this assignment, we are going to explore the, first of all, we are going to explore the data. In that data, we are going to consider only two columns. So that are comment text and what is the toxic content. So that we are going to read all the. So we are going to read the CSV file with these particular two comments, two columns, and then we are going to like print all those. So in order to make sure that we got some common text and toxic, and 0 is equals to not toxic and 1 is equals to toxic. So and then print, that means here that is that column, that toxic column is been like it's been written, it's been given as 0 for not toxic and 1 for toxic. So then whether the comment, sorry, whether the context is toxic or not. So then we are going to have we are going to count the toxic content, and these are the total data points. And since the data is heavily imbalanced, class toxic is equal to 1 only has 10% of data, that class has more data. So we are going to balance it by considering equal data points for each classes. Also, we will work on small subset of data. So we are not going to work on whole data. We are going to work on small subset of data, that is 5,000 data points. So where toxic is 1 and take the first 5,000 rows. Okay, select the rows from the first data frame where toxic is 1 and take the first 5,000 rows. So here we have taken so toxic is 0 within 5,000 and toxic is 1. Select the rows, second data frame where toxic is 0. And then we are going to concatenate the two data frames, and two data frames after balancing the whole data frame, we will be getting the required data frame or required data set for our particular assign for our particular model. And then we are going to list out the like before balancing, after balancing, before balancing non-toxic and toxic, before balancing non-toxic and toxic. So the final data is 10,000 and 10,000. So now the data is being splitted into training and testing with the 10% as a testing size. So after splitting, we'll get 9,000 and 1,000 because we have 10,000. So next, this cell will take about a minute. Like tokenizer, we are initializing a tokenizer, and here we are using word tokenizer, that is bidirectional encoder. Sorry, bidirectional encoder representation uh, transformer tokenizer. Uh, BERT based uncaged, and we are going to use this xtrain tokenized and xtext tokenized inside the function of tokenizer. We are giving xtrain and xtest with the maximum length of 512 and padding as true. So after that, we are going to explore the tokenized inputs. We are going to explore the tokenized inputs by printing those keys. We have printed those keys, and also we have printed the length of the, like we are checking the each dimension, that is 512, 512, and 512. So these are the dictionary keys, input IDs, tokenized type IDs, attention mask. So each data point has three dimensions. That is, it has three dimensions. So input IDs, the tokenized input sequence. So the and token type IDs and attention mask. These three are the dimensions of particular data point. And now we are going to use the helper functions, that is PyTorch dataset class. So using this PyTorch dataset, we are going to encode the data using input IDs, and then we are going to create a PyTorch compatible, these transformers work in the parallel, like it computes parallelly. So we are going to make it compatible for parallelized dataset from our data. And here is the training dataset and testing dataset. We are giving the input, we are giving the tokenized explain and tokenized x test as an input, and then we are going to print the training dataset with the first six rows. So we are going to get these particular dataset data, and then we are going to obtain the pre-trained BERT model. So already pre-trained bird model we are using in this. So for that, we are going to use this function BERT for sequence classification from pre-trained. So we this is the uh, and then we are going to, so this is the model that we have been using, the pre-trained bird model we are using. So and then we need to, like, in order to make sure that like what is the description of the model, we are going to print the model and then print the number of trainable parameters in the model. Like what are the trainable parameters that we are training in the model is 109483778. And then next we need to load model to the GPU, that is model.to. In the comments we are going to we're going to use Cuba. And next this is the exercise one. In this natural language processing, and in this exercise one, we are going to finish four tasks, that is accuracy, recall, precision, and F1 score. We are going to calculate the four metrics. So for this we are going to use a skykit learn metrics. So for that, for to compute the metrics, we are going to make a function called we need to define a function compute metrics, and we are going to give the data and uh, prediction comma labels is equals to datum. And that means it is a combination of two particular two particular variables, prediction and labels. So we are giving as a datum, and prediction is equals to numpy dot argument of max, argument max of prediction comma axis is equals to 1. And then next, accuracy, recall, and everything will be calculated using the already inbuilt function accuracy score, recall score, and prediction score with the particular labels that we have given. And then we will be returning this accuracy and all. And then training setup. So for we need to train the model. For that, we need to give the number of epochs. That is how many times it is going to run. And for that, in the arguments, we have given the uh, training arguments, and we need to pass all these variables, and then like. Write a trainer does not train it. uh, we just setting it up. So we are just like setting it up. We are not, didn't train it. So we just need to set up with the uh, suitable values in it. And the next is we are going to start the actual training. So we are going to store that results in the trainer.train. So after after training, we need to save the trained model, and in that we are going to give the number of epochs as arguments. And next we'll be getting all these values, like training loss, validation loss, accuracy in every step. And the next we are going to uh, we are going to load the model that was trained. Like we are going to load the model that already trained. And so here it is already, like we are using a large data set. So for the natural language processing, we are using a large data set. So we just need to clone the like classifier from the git, and then next we need to unzip it, and we'll be it takes some time. It takes some time, and it will download all the necessary model. And the trained model is been given. Trained model is BERT for sequence classification dot form from tree train, and this is the model that we have already given. And then we need to show the uh, like results. For showing the results, we are using this function. We need to the model output is 2D real number, that is logits, and the applies of like whatever the model that we have created that has given us a uh, that is a 2D real model. So we'll be getting predictions using this function, and these are the inbuilt functions. And then next we need to calculate the results, that is not a toxic comment or toxic comment. We need to, like, what is the possible results. So and then we will be getting the confidence levels. The next exercise is we need to apply the tokenizer to we need to apply the tokenizer to the input. Make sure include return tensors is equals to 1 as a argument to the tokenizer. Uh, so we are giving some new 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 sentences to this model. So these are the model, like we are using a comment data set. So where we are giving some comments, and we need to find whether it is a toxic comment or not. We are giving some comments that are toxic and non-toxic. So for everything in this dictionary, it will be taken as an input, and for every tokenized input, we are giving uh, all these variables as parameters, and then we are already taken return tensors as PT, and then tokenized input is been given into the model, into the GPU, and then we'll be getting the outputs, whether it is like toxic or not. That means what is the confidence level of it is like toxic or not. That is, it is giving model output as not a toxic. That means thanks for the encouraging review. That is not a toxic. So in this way, we are going to, like, we have tested it with some particular new sentences. So that would be very much uh, helps in understanding what is the confidence ratio and all. Thank you.